The difference between absolute and relative. The question, how would the AP ask for absolute besides saying absolute?
That's first degree.
No.
First degree.
How would the AP ask for absolute without saying absolute? They do that sometimes.
Relative.
The. Can you guys go ahead and take this the or the? Remember these sound snazzy? And circle it. The minimum. The maximum. The minimum. The maximum.
And how do you find it? You plug it into a calculator with the second trace.
E for effort. They're not going to give you an absolute extreme one on your calculator. Good try. So we know extreme value theorem. This is from last year, EBT. If a function is continuous on a closed interval, then we know the function has to have a highest and a lowest. And how do we test?
First degree test.
First, we're going to test critical numbers, but we test the critical numbers with the
Second.
Original function. Oh my goodness.
First derivative.
Yeah, the first derivative is that pause. Shush. Let me help. You're right. Take the first derivative, set equal to 0 in DNE. Critical numbers.
Yeah.
But if we're looking for the extrema, the absolute extrema, we need to test critical numbers with the and that's what I was looking for. Thank you, thank you. Now, let's go ahead and pause. We're thinking about relative. You can see a relative max, a relative min, and a relative max and a min from an original function. That's obvious. You look at it and say, hey, it's higher there. It's lower there. It's higher there and lower there, right? But how would you see it on the derivative function or in the derivative graph? Question. Where's the derivative at 3, 2?
3.
0, because it's a horizontal tangent line. So at 3, your derivative should be there. You guys agree?
Yeah.
What's going on to the derivative as it comes in towards that? Is it decreasing down to 0 or is it increasing down to 0?
It's increasing down to 0.
Because you have positives getting lower to 0, right?
Yep. Of course.
Something like that.
Mm-hmm.
Now what's going on? Going negative.
Straight.
Straight though?
Is it straight?
I'm not sure it's getting more and more negative, is it? The slopes are kind of seeming to go negative and then kind of leveling off. Kind of like this sort of thing, maybe? Well, how do I know this? Ready? The original function is concave down until here, and then what does it start doing? Apparently. Doesn't it start going concave up?
Mm-hmm.
So doesn't the derivative need to decrease and then increase? It seems to be getting flatter. Anyway, long story short, how do you see the relative maximum on the graph of the derivative? It is in this one. The relative max is a 0 where f prime changes from, what would I say, AP staff?
Positive to negative.
Positive to negative.
At.
Where? I just put a comma, right? Put a period. I could just stop.
Yeah.
I have a relative max at x equals 3 since f prime of 3 equals 0. Let's just stop there. F prime of 3 equals 0. Where?
Because
And is the point at which? That sounds better. F prime equals 0 and is the point at which f prime changes from positive to negative. Anyway, I should have just started making the entire statement and I didn't. I was trying to shortcut it and then it sounded awkward. Lowe's hands up. Number next one. Oh, wait, sorry. Where's that? Yes.
so if second derivative has to go with concavity, do they have one for third derivative?
Not as far as a characteristic of the original function. The third derivative would be the concavity of the first derivative.
Yeah.
It would be the slopes of the second derivative.
Like there's no nothing like the original function there.
I don't know why that's interesting.
Yep.
I mean, I know the jerk is a rate of change of acceleration, but as far as a characteristic on the graph, that's a good question, Corey. I don't think there actually is a specific application. This one, Gabby.
Yes.
How'd you figure out the graph of him?
You looked at the slopes.
Okay, good. And what's the slope of this side?
1.
because it's just y equals mx plus b, right? What's the slope of this side? So what'd you do for your derivative?
X equals y equals 1, and then y equals -1, but neither of them equals 0.
Exactly. Why do I have to have a hole on the first derivative at x equals 0?
There's no such thing.
Sharp point, the derivative does not exist. Good. Now, pause. But isn't this still a relative minimum?
Yep.
So what does that remind us? Not only can the first derivative equal 0 and have a relative extrema,
It can
where
be
the function changes from increasing to decreasing, the derivative changes from positive to negative, or vice versa. But you can also have a relative extrema when f prime of 0 does not exist. As long as you still have a point on the original function, as long as the original function is continuous. And as long as you still have a sign change. And this one, sign changes from
Negative.
negative to positive, which is why we remember we have a relative minimum, right? Am I reviewing kind of the relative extrema tests? Increasing and decreasing, and how do you get a relative minimum to max? Now, maybe this one was either super hard if you thought about it visually like these two, or maybe it was super easy if you just thought, derivative of sine is. Alright, could have cheated. But how does that work? Don't I have a 0 horizontal tangent here? And don't I have a 0 horizontal tangent here? And don't I have the function decreasing to that 0? And then decreasing until a change in concavity, and then he starts increasing? Oh my goodness, he's cosine. Whether or not you memorized it. It's true, but does it make sense graphically? Maybe. But once again with this one, don't I have f prime of, there's zeros where the derivative changes from this one? Can I do it just my old fashioned like this? I have a 0. And my derivative is positive to negative, so what do I have here? A relative max. And then I have a 0 where the derivative changes from negative to positive, and what do I have here? Do you remember how to find relative extrema?
Yeah.
We define critical numbers, which are when the first derivative equals pitchfork either 0 or DME, cheater right there. 0 or DME, and you need to check the signs of the derivative to see if there is a sign change. If there is no sign change, is there a relative extrema? And the answer is no. Pause.
Yes.
Do you need it?
Yes.
Let's review. We were just doing that, weren't we? How to find relative extrema. You can write whatever you do or don't need. However, I have given you guys a few AP-ish things. First of all, check the domain, because if a function is not continuous, it can't be differentiable.
No.
No, we need to be aware of that. But we also need to think about if it's not continuous at a point, can it have a relative or max or min there? No, so we have to check the domain just to see, wait a minute, if it's not in the domain, it better not be a max or min, even though it might show up on my sign chart. So we need to watch out for discontinuities. We have to exclude discontinuities from possible relative extrema, from relative extrema candidates. Then, you guys know, first derivative, we were just talking about this, pitchfork, right? Find the horizontal tangents and the VTLs. Our book would say the stationary points when the derivative or the velocity is 0. Stationary, you're not moving. It's a way of remembering. Or the vertical tangents. Does every derivative have denominators? No. So does every derivative have DNEs to be looking for? Not necessarily. But then, do you guys see how I'm like, hey, use the first derivative test sign chart and or the second derivative test? You guys know the AP sometimes forces your hand and only gives you clues about the second derivative. But otherwise, you get to choose. First derivative test is great if you can find the first derivative and plug in before and after each of our candidates. I'm going to zoom in on those sign charts in just a second to try to point out a couple key things as to where we might get stuck. However, if you're not writing down all of this, what do I still want you to write down? 1, 2, 3, and 4. 1, Watch out for domain. 2, critical points pitchfork. 3, first derivative test. 3a, first derivative test. 3b, second derivative test. 3a, first derivative test sign chart. 3b, second derivative test concavity. So you don't necessarily need to write all of it. The functions I said to watch out for with domain are nth roots, even roots, logs, and tangent. Technically could be rational functions too, I suppose. So even if you're not getting all of it, still get the main idea. That you can refer back to your forever cards, that is true. So 1, watch out for domain. If the function doesn't exist, you can't have a relative maximum in there. 2, critical numbers. 3a, 3b. Let me go ahead and change that right now because that's annoying. Close in. 3a to 3b. How do we actually prove what's there without our calculator cord? That was aimed at 3a.
Oh, you plug in.
Gotta plug in before and after. Figure out the behavior. Now pause. One of the most common mistakes made in describing a sign chart. Well, first of all, some people make a sign chart in justification or rationale for a relative extrema, and the AP graders are not allowed to grade a sign chart. They're not allowed to give you credit for a sign chart. They only give you credit for the words that come from what the sign chart shows you. So one mistake that a lot of AP kids do as far as the testing. So they show the sign chart and they say, ta-da, the answer is relative max of this one, just because of how I set up the example. Relative max at A, relative min at C, and they say done.
Wrong.
So you can almost guarantee it said justify or explain. This does not justify or explain anything.
It justifies your words.
It justifies what you're about to hopefully say. It forms the rationale that hopefully you're going to be able to explain.
How do you read?
Huh?
This monkey.
What?
How do you read? I don't get it.
Wait, I didn't know I did wink. Did I wink?
No.
I do sometimes, but I didn't remember that one. So coming back. If you do have the know-it-all to actually put the sign chart into words, what do you think? If you were talking to a calculus AP kid and they were studying for an FRQ test on this, what do you need to make sure they have straight as to how they're going? Definition? Maybe.
The numbers?
They can put this into words.
What do you think one of the most common mistakes is? They would say, in describing a sign chart and putting it into words, they would say something like, F changes from positive to negative, or F prime changes from increasing to decreasing.
At what point?
You have to say at what points, but also, did you hear?
That was messed up. It was supposed to be switched.
F prime changes signs. F changes from increasing to decreasing. If they mix those two, they're not getting any credit. Does that make sense? Because it means something totally different. So increasing, decreasing goes with behavior of an original, right? Which is proven or shown by positive or negative of a derivative, right? The derivative being positive or negative, the signs of the derivative indicate the behavior of the original. Very important to have solid down. And then second derivative test, that's the one where they force your hand, they only give you clues about the second derivative at C. There is no way to test before and after, so there is no way to do a sign chart. Remember, sign chart, you have to test before and after. If it's an at, and that's the only clue you have, you're testing for concavity. And then from that concavity, you're checking, is it a min or is it a max? However, how do you prove with the second derivative test?
I mean, if the off, then it's a min.
True, but that's not enough. The most common thing I take off points for the first and the second derivative test is you have to tell me it's a critical number first. There's no possibility it's a min or a max if it's not a critical number. I don't care the concavity and I don't care the sign chart if you didn't find the critical numbers first. So for both the first and the second derivative test. Thanks ASB kids for your service. Have fun with the crazy middle schoolers. Alright. They're handing out Dodger merchandise, something. All right, let me give you guys a second. Why don't you go ahead and graph what you see about the graph of a function f. Let me try to see. You guys can tell why I did all these. A is the 0, B is the max, G is the point of inflection.
What?
C is, I know, we kind of didn't out of order. Yeah, we put it in order.
No, those G point reflection, that point's like above and down.
Point of inflection. Concave up, concave down.
Oh.
Yeah.
That'd be.
C is the 0, D is the min, E is the 0.
What is E?
The 0.
E.
F is a vertical aspect. That got intense. I tried to put as many different possible things in here, except for, ooh, I did not do a sharp point. I should have thought of that. That was it.
Steve, that's this. No, that's not. Use a big E as sharp point. You're fine. That's good to know. That's not different.
That is true. So F prime of F does not exist. Change this to domain. Change this to domain. Yes, this is the graph of F. Sorry. Okay, I actually wrote that. Last year, basically, I drew the graph and I told them to tell me everything they could possibly remember or think of about F prime and F double prime. So it was a little hard. They didn't have a lot of direction. They had to be super creative and just keep on thinking. So this year, I kept some of the different things we came up with to see how we can fill them in.
Same pepper. Yeah, I need to sneeze really bad.
I'm looking into the light.
What did you say? I'm trying, but it's not at that point yet.
Or if you
Anybody have any like
or if you push like the bridge of your nose,
concepts something? What's that do?
it like takes away the tingling.
Oh, say pineapple.
Pineapple.
Maybe not. Maybe it's not that close.
Apple pie. So there's sense the word by apple pie.
You can just smell my air freshener. See if that makes you sneeze.
How much peanuts did they cut off your nose?
Oh wow. She like snorted a bunch of pepper and she didn't sneeze and I was like, you didn't put enough in your hand. So she put more in her hand.
You're a horrible
And I was like,
I'm so proud of
That's
you.
bad.
Yeah.
I don't think you're supposed to snort anything.
Yeah, don't snort. Don't
And
snort.
pepper's in that category.
stuff.
Okay.
I'll snort everything that comes out.
Just say no.
Painful.
I do not approve this message. Yeah. Okay, so F prime. How do we say or how do we describe F prime on a graph of F? How would you tutor someone? How would you explain it to them? How do they see? How do they think about it?
okay, so
Yo.
it's positive until B and then it's negative.
But just in general, the slopes of F, right?
Nope.
F double prime. Corey, how do you visualize F double prime on a graph of F?
It is concave down from negative infinity to G.
In
So-
general, but yes, concavity. Good.
Oh, I got you for that then.
Thanks. How do we think about F?
Just look at it.
Ah, but look at what part. Not everybody figures that out.
All of it. Everything.
Ah,
Specific. So, slopes, the points he gave us, the
the Y
lines,
values.
the Y values, of course. That's what I'm referring to.
Okay. So, question: what is the domain of this function? What's the domain?
All real numbers except F.
All real numbers except F.
F.
Okay.
But F isn't a number, it's a letter.
Indicating a value. Okay, increasing. Sunday.
Negative infinity to B, D to F, and then F to negative, F positive infinity, I think. Unless it's going like.
You guys agree with F to positive infinity?
Yeah.
Yeah, y'all better agree.
Hey, that's not how we do
Thank
things
you
here.
for agreeing.
That's better. Decreasing,
Whatever I didn't mention, B.
which was B to D.
B to D.
Keeping all the intervals negative, true? What can we say then about, if we know increasing, what do we know about F prime?
We know it's positive and negative.
So that'd be the exact same intervals, right?
Yes,
Yeah.
ma'am.
It's negative infinity to B. What else do we have? D to F? What do we know about F double prime from the increasing or decreasing of F prime? What do we know about F double prime? I
We know
didn't
where-
explicitly state it,
You know where that is positive and negative.
right?
Yeah.
Yeah, we're not necessarily thinking increasing or decreasing for him.
Where it changes.
Yeah, but hold on, we're not there yet. That'll happen down. Yeah, we're not there yet. That'll be the next one. F double prime. If F prime is positive, well, hold on, wait a minute. Looking up here, F prime is positive for a concave down portion, right?
See.
And F prime is positive for a concave up portion, and F prime is positive for a concave down portion. So what's in common with our F double prime? If we have different concavities, that means the sign changes, right?
Yep.
So are we able to say anything about F double prime just from the increasing, decreasing of the original graph? Because the original graph can increase on part of can increase and be concave down, or it can increase and be concave up. And so if the second derivative is concavity, we know nothing from the first clues. But what do we know? Or what can we tell F double prime from? Yeah, we can figure out when it's positive, when it's negative, based on looking at the concavity. So, on increasing, decreasing, that tells us about F's behavior and F prime sign, but doesn't tell us anything about F double prime. Because it can be true regardless of what F double prime is doing. But then concave up, concave down, well, where is the original function concave up? Yeah, from G to point of inflection all the way to F. Is it concave up anywhere else? The answer is no. And then where is it concave down? And? Negative infinity to G, concave down, but also from F to infinity, right? So, with the concave up portion, which is right here, what's going on to those slopes? Don't even think about the Forever card. Can you get the concept? You'll remember the Forever card if so. If slopes are negative going to 0 and then going positive, what are the slopes doing? Negative to 0, 0 to positive. Yeah, and how are they changing? They're increasing, right? So I can say where the original function is concave up, the derivative is increasing. Going from negative to 0 to positive, that's getting higher. And where the slopes are, where the graph is concave down, what's going on to my slopes? Positive to 0 to negative, decreasing. So I can go ahead and steal these. And if the derivative is increasing, what do I know about the sign of its derivative? if a quantity is decreasing, what can I tell about the sign of its derivative? So when we saw the increasing, decreasing test last year, it does work for original functions to derivatives, but it also works for derivatives to second derivatives to third derivatives, etc., etc., etc. Where a quantity, whatever it is increasing or decreasing, its rate or its derivative is going to be positive or negative. Quick reminder. But what's different once you're looking at the first derivative is that you can always go backwards, or you can also go backwards and talk about concavity as well. Okay, so this one, we have nothing to fill in. Some people think you can, but you can't, because the increasing, decreasing nature of f, aka the signs of f prime, do not tell us about f double prime. We have to look at how f prime is changing, how the slopes are changing, or the concavity of the original to figure out about f double prime. Corey, do you have a question?
Yep.
I think that was enough.
It was.
Okay. So, I don't know if you guys necessarily need to write this down. This is kind of what I was trying to pull out from the page before. Trying to make sure that you guys know the difference between signs and behavior. So the behavior of the original can be seen by the signs of the first derivative, and the behavior of the first derivative can be seen by the signs of the second derivative. And so when they say things like, when is velocity, oh, I don't like that, because that would be speed, and that's a whole different thing. When is the rate increasing? What do you have to think of? When is the rate of f increasing? When is the slope increasing is a synonym. But when is the rate increasing? When is the slope increasing? You have to look at the, no, that's going backwards. Second derivative sign. So when is the rate increasing? Who do I need to look at? The rate's prime. Who's the rate's prime of an original function? The second derivative. And so when they ask about when is speed increasing or decreasing, do we need to look at acceleration, yes or no? If speed is increasing, decreasing. Acceleration is important, its derivative is important, but then we also have to compare it with the signs of velocity to make sure everything matches up. And kiddos, we already talked about, and I reviewed it at the beginning of the section, maybe I just reviewed it a little bit earlier, but absolute extrema, what's different between absolute and relative? Relative, all we have to look at is the critical numbers. All we have to look at is the critical numbers, because all we care about is local or our local regions. The problem with absolute is it's needing to be the very highest and the very lowest. So we do need to find critical numbers and endpoints, but here's the dilemma. This whole process only works if we're given what kind of interval? So then here's the struggle that you might need to write down. Yes, for finding absolute extrema on a closed interval, we have our nice little struggle card. Find the critical numbers, the endpoints. Test them by, plugging them into where? What are we plugging into? The original function. Plugging into the original function. Common mistake. Plug into whatever it is that you want to find the max or min of. Very highest will be the absolute max. The very lowest will be the absolute min. But the dilemma is, and we saw the deep tank last year, and you didn't like it. What if there are no endpoints? AKA, what if the interval is not open? And technically there are another time, or there is another time when we might have to worry about this. What if there are no endpoints or discontinuities? Because this one says, on a closed interval A to B, when f is continuous. Two very specific things that have to be true. So tomorrow we're going to have to look at what happens if we have no endpoints, if we have an open interval, and or we have discontinuities, then what? So if you can just kind of rationally, logically go through it last year. I just need to make sure that you guys are good. We have one example? Two examples? We're basically done. But start homework. You'll probably have tomorrow night where you can finish. Okay? We don't have our notebooks. There are two up here, and then Cameron has the other four that just got created during class.
Welcome to my crib.
Sounded like Josh.
B?
Yeah.
Did you say shut up, Asian?
Yeah.
Josh.
Don't bob the poor man's kids at lunch for Dodger kids.
Yeah.
Which Josh?
Football Josh.
Football.
Who's football, Josh?
Lima blanket.
There's Big Josh and Skinny Josh.
Big Josh.